So hi guys, maybe some of you already know me. I'm in Sisense for quite a while. I am managing the BI consulting team, and that means that our specialty is take business questions, business scenarios, and translating it into data needs and into dashboard needs. And during today's webinar, we're going to touch some very basic elements, very basic concepts of data modeling and Elasticube design. So stay tuned and feel free to ask questions during the webinar and afterwards. Okay, so let's start. Okay, so during today's session, we're going to touch the following topics. I will walk you through the Elasticube building workflow, which includes identify data elements, fact and dimensions, transform and manipulate the data elements, how to perform relationship and uniqueness tests, and how to create relationships between the different data elements. Those four topics is relevant for any Elasticube design. Okay? So before we even start, let's ask ourselves, why do we even need to model our data? And so we have 5 major motivations behind it. First of all, we model our data in order to handle complex data from different data sources, okay? Many times when we need to migrate and consolidate data from different sources, for example, your company CRM, from your operational systems, from your healthcare systems, from your Google Analytics, Google AdWords. One of the challenges in data modeling is to make the different data sources communicate with each other, so we can, compare between it, okay? The second motivation is the one version of the truth concept. One version of the truth in terms of data quality. We want our data to be accurate and consistent. And we also make sure that all the organizations take decisions based on the same data. So for example, we might get the employee data from our HR systems and from our CRM, right? We need to somehow be aligned on the concept of employee, okay, or on the concept of dates, or on the concept of net value. Another motivation behind modeling our data is to allow multi-dimensional analysis. When bringing together many data sources with different level of granularity, we want to allow our end users to analyze everything from any dimension, right? We want to analyze our data from multiple levels. So this requires consolidate the data into as less entities as possible, okay? Another motivation is to support scalable analytical requirements. So maybe in the beginning we need our BI only for the finance team, but eventually we want to scale it and involve our HR team, our customer success team. So when we start correct and model it right, it's more easier to add more layers to our data model. And the last motivation is to support better data retrieval and processing. We want to get the entities that are, let's say, queried a lot together, closer to each other. Okay, and again, we'll get back to those motivations moving forward. Now, there's the answer to all those challenges is good Elasticube design. But what is Elasticube? What is it good for? So Elasticube is a data analyst engine where data is functionally oriented, integrated. It's time variant, meaning the data can be always related to time, and it's able to support. We are doing all of this and the Elasticube. And remember, guys, a good Elasticube is a prerequisite for successful BI. So very easy, very difficult to go back and change things. Very, very important to put emphasis on good data models. Now, let's discuss the principle that guides the design of Elasticube. First of all, Elasticube is there to support analytical usage. It starts and ends with the business. You need to understand the business question. You need to understand the business word before starting. So in the Elasticube, we are restructuring the data to provide a better support for the BI application. Okay? So understand the business, because on the same data elements, same data sources, you can model the data completely differently. The second principle of Elastic design is the fact that it's subject-oriented. It's a cross-functional understanding of the business subject, not the operational way of looking at it. Meaning the concept of customer, even though it's coming from different sources, we want to bring it together. The concept of sales too. For example, if we get sales from many, many different sources, we want to bring it together. We want to consolidate similar data elements. Same about employee, location, dates, okay? It's a very important principle, and we'll get back to it. Another principle is the fact that we are integrating data view. We are bringing together different aspects of the firm together. Production, marketing, finance, logistics. We want to make those different aspects of the firm communicate with each other. We want to find the common dimension. We want to find the common fact, and we'll get to it. So, from my experience, every Elasticube design contains five steps, five very important steps, and we shouldn't skip any step. First step is identifying the different data elements. Analyze your data sources and know your tables. Second step is import it. Remember, we are starting with understanding the business sense, business logic. So we import only the data elements that are relevant to answer our business needs. The third step is to transform and manipulate the data. All the manipulation we apply on it in order to shape it in a way it will be a good base for dashboard creation. The fourth step is connecting the data elements, connecting the tables to each other. And the fifth step is verifying that the results are correct, and we are good to move on to the next iteration. Remember to start small. You don't want to bring all the data elements together and then understand you did something wrong. So always start small and extend the model every time with additional data layer. Okay, so in order to make it interesting, I brought you a use case, which is AdventureWork. AdventureWork is a fictional company on which the AdventureWork sample are based. The company manufactures pedal and composite bicycles to North America, European, and Asian commercial markets. Coming off successful fiscal year, AdventureWork Cycles is looking to broaden its market share by targeting their sales to their best customer, extending the product availability through an external website, and reducing their cost sales through lower production. The main business questions they ask themselves are: do certain stores sell bikes significantly better than others? What brand was top seller in the country last year? And who are my top 5 customers in terms of revenue? Remember, a good Elasticube model starts with understanding the business. So what we're going to do now is we're going to try and recognize an inquiry structure within the business questions. The elements that we're going to look for are the facts, the aggregations, the measures. We will look for the dimensions, the business subject of what we want to analyze. We will look for the filters, a set of conditions that specify the data subset that we want to look at. And we also look for the order in which we want to see the aggregation. Let's start with the first question. What brand was top seller in country last year? Okay, so by candidate, candidate from, you can just type it, okay? Based on the above, what are my dimension here? Or what is my dimension? You can just type it into the chat box. Let's see. Tracy, don't disappoint me. I know you're there. Tracy is one of my favorite customers. She's on the crowd. Okay, right. Okay, so yeah, we got some interesting answers. Okay, so yeah, indeed, brand is my dimension, correct. What is my effect? Yay, correct. Good to go. Who voted first? Raj. Great one. So yes, sales are my effect. How would you say, like, what is the top? What does it refer to? The top, like, no, from the data elements that we mentioned. Top would be the max. I was more looking for the order, because top it refers to the way we order, right? And last year, what is last year? Is it dimension or filter condition? Right. Go ahead. Yeah, correct. So as you see, you nailed it. Brand is my dimension. Top is the order. Seller refers to the fact, which is sell. Country is another dimension. And last year is the filter condition. Now let's move to the next business question. Do certain stores sell bikes categories significantly better than others? What is my fact here? Bike sales, correct. What is my dimension? Right. Do we have another dimension besides stores? Yeah, good to go, Raj. You're the winner. Okay. Significantly better, how would you define it? Yeah, it can come in percent. So when you see the significantly better, you should go to your boss and ask him define it. But in this case, I was more like I was referring to the order in which you want to see the result. And do we have any filter here? Right, we're good to go. Pavlos, you nailed it, correct. Okay, now, who are my top 5 customers in terms of revenue? This is the last business inquiry. Okay, so what is my fact here? Right, correct. And let's move on. So customers is the dimension, top is the order, 5 is a filter condition, and revenue is indeed my fact. Okay, so we understand how to extract the different data elements from a business inquiry. So let's analyze what does this even stand for? So dimensions, as we mentioned before, are my key business entities. It's the subject that we want to analyze. Fact are my performance measurements, the measure itself. It's the way I'm measuring the dimension, okay? And filter and orders are the set of condition and order that specify a data, that specify the data subset that we want to look at, okay? So during this discussion, we will touch dimensions and facts because filters and order are more related to the way we visualize the data. And today we're here to discuss the data modeling. So dimensions and facts are concepts that are related to the Elasticube. So let's move back to dimensions. Dimensions are mostly categorical, and it has a discrete set of values. It usually has a key, an attribute that identifies each dimension in instance uniquely. A dimension can be customer, can be product, can be employee, can be anything that we measure. Now facts are my measure itself. And they're usually, or I think always, presented in the aggregated manner, aggregated format. We can apply max, sum, average, variance, median, count, year to date. Fact tables are tracking occurrence of business events at the most detailed level. They're usually time variant, and we recognize them by the fact that they have the highest level of granularity. They're the most detailed, and they're large and grow fast. So what we'll do now is we start to see if we can identify the data elements in our data model. So let me introduce you with the data table. We have an adventure bar. Let's wait until it appears on the screen. Okay. So let me improve the resolution. Okay, and again, I want to involve you guys in the verification step. I will point on a table and you tell me if it's a fact table or dimension table, okay? So, product is a fact or dimension? Right. What about product subcategory? Right. What about sales order details? Right. So how do I know it? How do I know that sales order details and sales order header are facts and product is dimension? Let's look at, for example, sales order header. We can find time here. We can find freight. We can find total due. We can find, the business instances itself. Those tables represent the transactional data. That makes them the fact tables. While product and product subcategory and product category refer to the business entities. We are measuring the performance of the product sales by attributes that can be found in the sales order details and sales order header. This is how we can tell. And I recommend you all, before even bringing the data into the surface, to know it and understand the difference between the dimension tables and the fact tables. Now let's move on to the next step, which is importing the data. So based on our business requirements, we understood that those are the tables that we need to answer our business questions. But it's not enough to know which tables that we need, because maybe tables contain hundreds and hundreds of columns which are redundant. What we'll do now is we need to bring only the fields that support our analysis, okay? Start small, very, very basic principle. So let's look, for example, on the sales order header. We have a whole bunch of details here, but as a matter of fact, order date, customer ID, okay? Sales order ID. What I will do now, I would uncheck all fields and bring only the fields I need. Customer ID, order date, and sales. Okay? It's very, very, very simple to do it in Sisense. You just field you need as imports and apply a build, and it's very, very recommended. Okay? So now you simply apply a build. And I made in advance an example of how it's been done afterwards. So you see here a schema of the same table with only the fields we need imported. You see? How you can tell a field is not imported? It's unmarked and it's a little bit blurry. Okay, so now we are happy because we imported only the tables and the data we need. Now let's back to the slide. So we identified the data elements and we imported only the pieces of information we need to support our business needs. Now let's start with the fun part, with transforming the data and manipulating it. This is an endless topic, and most of my time as a BI consultant is invest in transforming and manipulating my customers' data. And today I'm going to touch two very basic manipulation methods. The first relates to the subject-based consolidation, and I will demonstrate it through the lookup function. So as I mentioned before, one of our missions as good data modelers is to bring together the data in a subject-related manner. So if I look closely at the table, I can see that those three tables are related to product, right? We have the product subcategory, and category. I see the product detail and product header are also related to each other. We can bring them together, or we can leave here for now. So what I need now is to somehow consolidate the header and the detail. Now, guys, tell me, what is preferred? To bring the header field into the details, or the opposite way around? You may answer now. Right, correct. Ryan said that into details. Ryan, can you maybe explain why? I will repeat. Right, low and grain possible, correct. Ryan, 10 points. Because the details is taking the header and it breaks it, right? It's more detailed. So every header can have multiple details. So we can refer to the header as an attribute of the details. So always bring, when you're looking up fields, only bring it from the one side to the many. And let me demonstrate it now. So we'll add new field. Let's start with bringing the order date because it's very, very important. It's the date. And now we will show you how to use lookup. So it's pretty similar to Excel. I'm adding the function lookup, and now I need to say, enter here the remote table from which we bring in the fields, and this would be the order header. The result column is order date, and the field we want to compare is sales order header from the details and the header. We will save it. Then we can look at the table. Remember, it's the biggest table, so it's pretty big. Just a minute. Okay, I know my computer is a little bit slow. A minute. Here we go. So now we have the order date for every sales transaction. Now we're not done yet. Let's also bring the customer ID because this will allow us to connect it to the customer entity. I'm lazy, so what I would do is simply duplicate this lookup because we need to bring it from the same table. I would change it to int. I will call it customer ID. And all I need to do is replace this field with customer ID. Now I have two fancy fields from the details to the header. Now we can make, oh, wait a minute, we have a new question. On lookup, what happens if the reference table doesn't have a record for the data lookup key? Will it return a row with null value shown or join, or it will return null value? Thank you, Arik, for the question. Okay, so if no value was exited here, I will simply, lookup behaves just like left join. Thank you, Arik, for the question. Now, when we looked at lookup, I would also look up the fields from category to subcategory to product. Same principle, okay? Again, consolidate the things that you can and make as many tables as you can redundant, okay? So in this case, I brought into details all the details I need from the header, so I can make this one invisible because I don't need it for dashboard. And then also good habit is to rename it. The way I know it's a fact table, right? It indicates that now it's a fact table. Same thing about product. I would add dim in the beginning, because now I know that this is the dimension table and this is a fact table. And no matter who will inherit my model afterwards, you will know right away what are my data elements. The second concept of manipulation I want to demonstrate is fact creation. How do I create a custom field in my data model? Let's move back to our model and create new facts in the sales fact table. Let's say I want to add my net revenue. I simply go here, add new field, and the net revenue I will change it to float, because it's not an integer we can, because since we are calculating a net revenue, it's we basically reducing from the gross revenue. The discount, it can be non-complete number. It can be so therefore it's a float. Now, how do I do it? I basically multiply the order quantity by the unit price, and from this I'm reducing the order quantity and the unit price multiplied by unit price discount. As simple as that. Saving and exit. And when I look again at the table, yeah, I need to build it in order to save the names, because I renamed it. Just a minute. By the way, you can either select build entire, which will bring all the data from the beginning, or build changes, which will only apply the changes we've made in the schema. And once after I make the build, you will see that a new field will be created in effect cells. Okay, now let's look at our effect cells. And we'll see that the net revenue column was added here. Okay? So those are two very basic data manipulations that we made. And we can make many more, but I will just send you example. Okay. Now, after we transform the data, it's time to connect it. Okay? So in order to connect the data, we need to discuss two concepts. First of all, we need to understand what are my dimension table keys, okay? Because I have to connect the dimension to the table, to the fact table, by the primary key of the dimension table. And we'll touch the concept right away. And the second thing I need to understand is the relationship type. So because between every two tables in Elasticube, we can have different relationship types. Let's start with keys. And then move back to the model. I prepared in advance a consolidated schema. This is the result of consolidating and looking up the subcategory and the category into the product. And this is simply a dim customer table. I also added the person table in order to show you some kind of some types of relationship. Now, when I look at the dim product table, I need to look for its unique key in order to connect it to the product ID. I suspect that product ID is the unique identifier of dim product, but never trust the names and never trust your model. You always need to verify and make sure that product ID is indeed the unique key of the product table. And I will show you a quick and easy uniqueness test. What I did now is add a new SQL expression. So remember, the purpose is to verify if a candidate key, which is product ID, is really unique and can be used as primary key of the dimension table. What I will do now is comparing the row count to the distinct row count of the table. So I'm selecting from dim product the row count, which is simply count of product ID. And I'm comparing it to distinct count. Distinct count is pretty similar concept to row count, but it removes duplicates. So let's do it. Now, before I'm showing you the results, the possible, I can get, oops, just a minute, let's go back to the model. I can get two possible results. First of all, that the count will be equal to the count distinct. This means that the key is unique and can be acted as a primary key. The second option is that the row count is bigger than the count distinct, and that means the key is not unique, and we cannot use it as the primary key. Now let's present the results. Yeah, so in the product case, the row count equals to the distinct count, so we're good to go. That means that product ID can be connected to product ID. We should apply the same test on dim customer, okay? Before connecting the person, the customer ID to the customer ID. Now, let's move to understanding relationship, okay? So when connecting tables in Elasticube, we can have three types of relationship. First type of relationship is one-to-one relationship. A one-to-one relationship is a type of cardinality that refers to the relationship between two tables in which one element of A one and vice versa. For instance, think of A as countries and B as capital cities. Country is only one capital city, and the capital city is the capital of only one country. So between capital, city, and country, we have one-to-one relationship. The second relationship that we might find in Elasticube is one-to-many relationship. A one-to-many relationship occurs when a parent record in one table is potentially referenced several child records in another table. In one-to-many relationship, the parent is not required to have a child record. Therefore, the one-to-many relationship allows zero child records, a single child record, or multiple child records. Okay? So for instance, think of an A as mothers and B as children. A biological mother can have several children, but a child can have only one biological mother. Okay? The third type of relationship that we might find is the many-to-many. A many-to-many relationship exists when the value in which field used to create the relationship between tables is contained multiple times in each table. In general, when a field from two or more tables contains the same value and these values are duplicated in both tables, the connection created based on these fields will result in many-to-many relationship. Those kind of tables, the relationship are problematic, okay? And we should not allow them in Elasticube because it can create complex data sets which do not return the correct results and can use excessive computing resources and do not return any results. So when modeling the data, only allow one-to-one or one-to-many. Many-to-many is not, the relationship is not allowed, but we will touch this concept afterwards. Now we have one question from Pablos. I'm repeating the question. Is there any, if there are duplicates when we should compare two distinct? I'm not sure I'm following. Can you maybe make the question more clear? Where should many-to-many relationship be corrected? That's a good question. Either way. But again, I don't want to touch today the many-to-many concept. We'll dedicate a full webinar only to this. I want to focus on the correct one. Okay? So now, let's check the uniqueness. So let's see how we can pretty easily test the relationship between two tables. And again, it's another Q test. So in order to check the relationship between two tables, for example, between customer and person, I need to first join customer to person. So between customer and person, we can have one-to-many, means one customer points to many person entities. We can have many-to-many, and we can have one-to-one. Let's see what are we getting here. First of all, I'm joining the two tables, but they're foreign keys. Now, let's see how many persons occurs in single customer entity. So I will take the customer ID, and I can count the number of customers it points to. Okay, so what I did now is I took for every customer how many persons, instances it has. And if I will present my results, I will see, and I can afterwards even add the having segment, I can see that every customer points to one and single person, okay? I can even take it to the next level and add having, meaning show me only the places where this count bigger than 1. And I get 0. That means that every customer has only one parent. So it means it's either one-to-many or one-to-one relationship. And now I will switch, vice versa. Let's see how many how many customers do I have in one instance of customer? This one I can. Vice versa, same thing. So I suspect that I have one-to-one relationship. Let's verify it. And indeed, between person and customer, I have one-to-one relationship. Okay? Another test I can perform is between sales and product. Let's do it real quick. Which is the entity I want to compare. Now, what we are checking now is how many sales order IDs can I find in every product, for every product. And now I can see that I have many sales order details ID for every product. So we either have many to many or one to many. Now I wanted to see if it's one to many or many to many. I will just do it vice versa. And now it is clear that every sales order ID points to only single product. That means we're good. We have one-to-many relationship between product and sales. And we have, I guess, one-to-many relationship between sales and customer. Okay? So we can connect them now. Just a minute. Let's make this one invisible. And run a build. Okay. So, now we have completed almost everything we need. And there's only one step we need to make, and this is the verification. We need to make sure our results are correct. In order to verify our results, we create a very, very simple dashboard, right? Pivot-based dashboard. Let's base it on our Elasticube. Let's call it verify. This is the stage where we are comparing our data to our operational system data. Oh, wait a minute, the Elasticube has been built. Okay, very good now. Okay. So now we need to just simply drag and drop the different facts and different dimensions and make sure the data is correct. That's all. Very simple. We can also filter it by time and never move on to the next iteration as long as the data is not validated, because we don't want to finish all our iteration and found that we have discrepancies. Okay, so this is the importance of the verification stage. And let's move back, and I think it's time for questions. Okay? Okay, so feel free to just submit your question. We'll take few more minutes. Okay. Okay. Okay, so Tim is getting an error when attempting to use the distinct function. Tim, use distinct underscore count. Okay? Pavlos asked if we have a script that checks the one-to-one and one-to-many relationship. Yeah, we will send it to you when we send this presentation after this webinar. Raj asked the advanced question, how do we handle many-to-many relationship? This is a good question, and we'll further elaborate on this and dedicate a webinar only to recognize and work with many-to-many relationship. That's a good one. I just want to keep it basic for now. Ryan asked about recommendation for date dimension. Ryan, you'll be happy to hear that in the end of this month, we have a webinar that dedicates only to working with dates. Rachel asked another advanced question, is how to handle slowly changing values such as rates. And Rachel, again, it's an advanced question. I can also send you some information about it. And we, again, dedicate a more advanced webinar to tackle those issues. Tim, it's distinct underscore count, not column. Sorry for making it not clear. Stefan. Okay, Stefan asked a good question. Stefan asked if there's any rules of what must be done as derived table versus what can be done directly on the dashboard. Stefan, I'm coming from the data modeling world, and as a data modeler, I recommend on calculating as much as possible in the Elasticube, especially with working with multiple designers. We want to chew the data for your designer as much as possible. So for example, values like net revenue can be calculated in so many ways. So if we calculate it and prepare it for your end users in advance, it just ensures better consistency among the organization. So anything you can, try and calculate in the Elasticube. This is my recommendation. Okay. Eric's want me to give you value add examples of pre and post execution script. Again, Eric, it's more advanced, and I prefer to keep it simple, the pre and post plugins. But you can find plenty of them on our website. Raj, we will send you the Elasticube that I sent, don't worry. You're welcome guys. Ryan, Ryan asked about the date dimension. Yeah, we can. You can find actually a forum post that dedicated only to working with dates. I wrote it, I think, 2 years ago. If you want, you can just send me an email, and I will just send it to you. Okay. Stefan, I'm not sure I understood the question. You're asking about transforming keys values table to then normalized tables. Can you maybe make it more clear? You can, if needed, you can also send me an email, and I will try to refer because we are running out of time.
Okay, so I think we really are running out of time. We've got literally 2 minutes left, and I'm going to take those 2 minutes to thank Hila so much for an amazing webinar. Really, really, really great. And thank Inbar again for really putting this all together. Just from the amount of participants we've been getting today, actually, we can see that this has been giving real value to you guys, and we'd like to thank you so much for taking the time to join us. You all got the email about the April schedule, and as Hila has been elaborating throughout your Q&A session, sign up for these webinars. We've got date webinars. We've got more advanced stuff coming up as well. So feel free to sign up to those. And also, we'd love to get your feedback. We'd love to get ideas from you guys. We take this very seriously. If you give us an idea for a webinar, we're going to do it. So we urge you to send us your ideas. And that's it. So again, thank you so much for joining us. Next week, we're going to be having more dashboard webinars. It's more of a storytelling through your dashboard. Feel free to sign up for that. It's going to be great as well. So yeah, we'll see you next week. Thanks and bye.